Okay, this is week 3, and we're going to talk about chapter 3, creating and working with ArcGIS Pro projects from the Learning ArcGIS Pro textbook. Obviously, this week we had a bit of a snow day, and class was canceled tonight, and I apologize for not getting this to you sooner, but my uh, internet and television have been out all day, and we just got television back shortly. I expect to have my internet up, so I'm going to go ahead and um, try to get these final narrations ready so that as soon as I have internet, I can post the video lecture for you guys to watch. So, creating and working with ArcGIS Pro projects, what does it all mean? Well, this chapter is about that basic sort of functionality, and then afterwards we'll look at a couple chapters from the other text as well. All about getting you ready to become more comfortable working in and with ArcGIS Pro, and going over sort of the basics again of just GIS in general. So we're going to be introduced to the concept of these pro projects and understand how to create them and what can be included and how to use them and create templates. So as always the case with Esri products, you have to understand the terminology to make sense of the instructions. So we're just going to go over a few of them. The first one here is a project item. This is any item, component, or resource stored within an ArcGIS Pro project. Basically, if you have a project, anything that you can store in or with it is an item. And there's portal items. Portal items are any object that is accessed via a designated portal. In other words, this is online or otherwise stored data that is retrieved by ArcGIS Pro. And then we have project packages. This is very similar to a layer or map package that you would have made in the other Esri products in the past. The home folder, this is a folder where the project file is stored. The default geodatabase is used by the geoprocessing tools as the automatic default workspace for the resulting output items of the tools. So basically, if you have a home folder where your project file is stored, it's a good idea to create a default for that project and stick it in that folder, and then any tools that you're using, as long as you're working in that setup, will automatically place those things in the default space there that you've assigned. So let's talk a little bit about using the project pane. When you open a project or create a new project in ArcGIS Pro, the project pane will be one of the first things that you see. It's on the left side of the interface. It's the opposite of the contents page. It provides access to project items, and it's where you can preview. You can view the project pane in two different modes: outline and gallery. So here's what we're talking about. So you've opened up one and you've got this new project, and you've got some multiple tabs at the top like project and portal and notifications, and you can view it in different ways as an outline or as a gallery, so that you can see exactly what it is you're looking at. Now when you're in project mode, you can see that maps are on one thing, custom toolboxes are on another. All the different connections are there, the servers where things are running at, the different styles and symbologies that you're using, assuming you adopt preset stuff, and any connections to folders and all that sort of thing, they're all shared right there. And basically that's it. This previous chapter is more about getting used to the custom of how things are structured, and it's more similar to the old ArcView than it is to the ArcGIS and ArcMap products that we've been using since about 1999. Now, I'm going to talk a little bit about Chapter 2 and Chapter 3 from the Esri Guide to GIS Analysis on Spatial Measurements and Statistics by Andy Mitchell. So the first thing we're going to do is look at measuring geographic distributions. Okay, and we're going to talk about why we do it. We're going to talk about the concept of center and compactness, as well as direction and orientation and what they mean. Why? Why is a really good question. Why do we do this? We do this because we want to place a statistical value on an inferred belief or hypothesis. In other words, you assume that this is different than that, or this is significant, and we do this because we need to be able to put some sort of statistical number with that to place some certainty on our statement. We can also use it as a means to validate or disprove the things that we see visually, and we can use it to track changes over time. Finding the center is another thing that is common, the central feature. You've got multiple features in the data set. It's the one that's most centrally located. The median center, the mean center. Again, these are statistically based terms, but they're not exactly the same thing. In a normal distribution they would be, but they're not. When we talk about the center, are we talking about the center by location or by attribute values? So imagine you've got a bunch of data points scattered across an area, and we're looking for the center. Are we going to look for the center of the locations or the center value of the thing that we're measured at the locations? And is that going to be something that's weighted or unweighted? The compactness of the distribution also tells us some things. The measure is a single value representing the compactness of the entire data set. Average distance features vary from the mean center. It equals its compactness. And so you've got 100 data points. You find the center. You say how far is it from each point to the center, and then you average those distances, and that gives you some measure of compactness. Obviously, the smaller that number is, the more compact the data is. It's possible to include an attribute value to weight the outcome as well. And so you could weight the impact of the value, or the impact of the distance by the value. One way of thinking about it. And then we can talk about orientation and direction. This can allow for better representations of the spatial distribution, and it can disclose otherwise unseen or unverified information. And we'll sort of give you an idea. You might have a really large cluster of data points that you don't see a directional pattern to, but when you analyze the distribution spatially and you look for these parameters and you apply the right stuff, you can determine that the cluster actually is pointing in a certain direction, and that may or may not be important. It may be an indication of some environmental factor like aspect or solar radiation that is important to the thing that you're measuring. It could give an indication of a general direction of travel. Think of a bunch of muggings or crimes in an area, and you look at the distribution of the data, and it seems to be scattered all over the place, but when you measure the orientation and direction, you see it follows a certain direction, and lo and behold, that happens to be this new road or path or bike trail or something that maybe a criminal is using to access victims. So how do you test significance? Well, basic concept is sort of based off of a z-score, where you're looking at number of standard deviations away from a mean. So negative 1.96 to positive 1.96 is at 95%. Plus or minus 2.58 is at 99. Now, if you don't remember what z-scores are, the mean is equal to 0 and the standard deviation is equal to 1. And so z-score is equal to x minus the mean divided by the standard deviation, with x being a particular value of note. And so you calculate that, and it gives you a score, and from that you can see the significance of it. Now, when we talk about statistics, there's some rules. Don't go fishing and other basic sort of things. There are no absolutes in any of this. You should always be testing a hypothesis. You don't use statistics as a means of seeing what sticks. In other words, you don't go running a bunch of tests and say, oh, look, yeah, here's one. This showed up as positive at a significant level. We'll investigate this, and then that's going to be what we're going to, come up with a new hypothesis about. No. What you want to do is investigate your data, develop a hypothesis, and then use statistics to confirm it. The other thing I want to talk a little bit about is type 1 and type 2 errors. Type 1 is when we reject the null hypothesis, but it's true. Type 2 errors is when we fail to reject the null hypothesis, but we should have. And ultimately, you got to remember that statistics are not the final answer, it's just a piece of the puzzle. The most important skill to develop is the ability to think spatially, and the most difficult skill to master is to think spatially. What does that mean? It means you have to look beyond just mapping things and understand the importance of the patterns that you see and what they mean and how they relate to data, how they relate to problems, and how they relate to the potential to solve problems. Now we're going to take a quick scatter at chapter 3. Again, look it over if you've got questions. So we've spent a lot of time talking about patterns. The next obvious questions are why, and how can we use statistics to ID them, and how do we measure them, and how do we measure values as far as patterns go. So this is a nice visual representation of what we see, clustered to dispersed. When your data is dispersed, things are as far apart as they can be, more or less, from one another. And as some of those points become closer to other points, it becomes less dispersed until you reach a point where data exists in tiny little groups, i.e. clusters. So here's a map. This is some of my research. And I looked at this particular field measuring phosphorus levels, and when I applied this GEDIS or GI-STAR test, it identifies hot spots and cold spots. Now a cold spot is low values surrounded by low values. Hot spots are high values surrounded by higher values. And then spots that are not significant obviously are more in the lighter shades of color. And what we see here is relatively low values in the upper half of the data set and relatively higher values in the lower half of the data set. But the highest values occurring in this transition zone in the middle. Here's another location. Again, same type of analysis. Nothing significant. A couple really low spots and a couple really high spots. And why? Well, turns out near this highest spot is where you come into the field, and the field is surrounded by a fence. And so as cattle move in and out, or you bring hay in and out to feed or fertilizer or whatever, everything nutrient-wise that enters that field comes through that point. So anything that's lost or funneled would be deposited there. Think of cattle moving in and out. There's a water source down in here. And so if they're up here and they need water, they have to come through here, get to the water, and go back out. And so the thing is, they can take lots of different paths through all these areas, but in this upper right hand corner is where they have to go in and out. And so that was where we seen the higher values. Consequently, the lowest values were among some of the places that were most remote in terms of being farthest away from this area. There are other ways of looking at things. Here we have a cluster of data, but what we're really looking at is the magnitude of the earthquakes, and we're displaying it by the size. This is another way you can sort of examine to think about whether data is clustered or dispersed. It's not so much just where the earthquakes are, it's where are the big earthquakes. So how do you use information like this? Well, the first thing it does is it allows you to have an improved level of understanding. What does that mean? Well, as you identify clusters and you see where things are at, you can begin to make sense of the other information that you know about the location or the data and how it may help support what you're seeing. You ask yourself basic questions. Does geography explain what we're seeing? Do we see high values in a corner because that's the only place in and out? A natural bottleneck feature? Is there something there that we need to be monitoring or watching or looking for? Is a cluster really a cluster, or is it just some random grouping? It allows you to compare data and then use actual statistics so that you can not just look at the values and the locations, but see whether those values and locations are significant. And we can use it to track change. But more importantly, it allows us to see if the change we're seeing is real. So what are some of the big things that you need to remember as you're thinking about this chapter moving forward? When you're looking at patterns, is it a global pattern or a local pattern? This is kind of important. Obviously, global patterns exist across the scale of your entire data set. Local patterns are isolated individual areas that exhibit tendencies that may or may not be consistent with the entire data set. Patterns of features and patterns and values are not the same thing. You have to think about what you're seeing and make sure that when you're looking at raw data and you see patterns and values, is it truly a pattern, or is it a pattern because of the location of the features? You can use things like quadrant analysis, which look at counts in areas of equal size to see if the distribution follows that. You can average distance between the number with an area. Any number of ways that you can calculate density are all valid things to look at when you're trying to make sense of data. Are the measures or counts scale dependent? Now this can be really important. What that means is, as we change the scale that we're looking at the data or that we're doing the analysis, will that change the outcomes? Will that change what you're seeing, the values you're getting, or the counts that you're taking? Remember that scale matters with patterns. Beyond just what we're just talking about right now, globally or locally, scale matters with patterns. So you need to understand the results. And here's I should give you an example here, I suppose. Coming back to that in a second. Know your role. Make sure you understand the tools that you're using. As an analyst, or even as a technician, really, if you apply a particular tool, you need to understand what the tool does, how the tool works, and what are the proper inputs for the tools. For example, nearest neighbor index is a measure of density. It assumes features are random, calculates z-scores, positive z-scores far apart, negative z-scores are close together. That's how you can tell dispersed or clustered. Now, back to understanding your results. Without getting too much in detail, there's several means of looking at these sort of spatial statistics to calculate things like z-scores. Now, they're not always going to be z-scores. Sometimes they're going to be other scores that they use to determine whether something is clustered or dispersed. And in some tests, positive values mean dispersed and negative mean clustered. In others, negative means clustered, or negative means dispersed and positive means clustered. So understanding the results, in other words, being able to interpret the output, is really important. And how do you get to there? When you use tools, read the help, and understand what it means before you go about using it, trying to explain it or make sense of it. So that's the end of that chapter as far as what we're going to talk about. And I'll talk about some more of them next lecture. At this point, what I want you to do now is focus on working on your lab activities in the textbook. Now there's 3 of them that go into it this week, and it's not really good exercises for me to grade anything by. So I'm going to post a writing assignment, and I'll put some more details on the next slide about that. But basically, read over your chapter and get ready. So I'm going to go on to the next slide and tell you a little bit about what I want you to do with the software to make up for the rest of your class. Okay, I'm assuming that you've listened to my lecture and you're ready to do your lab or your hands-on learning exercises, we'll call it. Basically, you need to work through lab exercises A, B, and C in chapter 3. Once you complete them, I want you to make a note of any place in the textbook where the textbook is no longer in sync with the software. Now, I'm sure as you went through Chapter 2, many of you recognized that towards the end of the exercises for Chapter 2, it was asking you to do something that didn't exist. Now, when faced with that, you have two options. You simply say, well, it's not here, and you skip it and go on, or you look for it and find it. And usually what happens is they've moved it to someplace else, somewhere that they thought made more ergonomic sense in terms of placement of the tool or the function. It took me about 10 or 15 minutes last week working with, I believe it was Emily, and we found where they moved the tools to in question. Now, here's what I want you to do. When you come across those things, make note of it. Try to find it. And then when we come to class the following week, it's an opportunity to share with your classmates what you discovered and how things are different. Typically speaking, if we're working on the newest version of the software, the textbooks are always going to be a little bit behind. And that gives us two options. We can work with an older version of the software, or we can work with textbooks that don't completely match up. I prefer to work with a somewhat newer software, and if things don't match up, we just do the best we can. Alright, so some things have been placed around, moved differently. Identify them in this lab exercises when you come across them, if you come across them. I'm not saying that there are any. I'm just saying if you find any, make note of it and be specific about where you found it and what it was. And then I'll make a link in Blackboard where you'll basically be able to put up and paste in like a paragraph or so of writing. Here's the thing. You can't write a new edition of War and Peace in terms of these answers. It's just too much information. So be brief. Step whatever on page whatever asked for this. It's no longer there. It's here, and tell me where it is. And so, one or two lines for everything that you find. I can't imagine you'll find more than two or three things at the most. And so a nice little short paragraph should take care of that. Once you've done all those and filled all those out, I'll look over them and we can talk about them in class next week. Okay, so now you know what you need to do. All you have to do is do it. Hopefully we won't have any more of these snow days because exercises are going to start getting more complicated once we move past these first couple weeks. These first couple weeks with this textbook are really about learning how to navigate and use the ArcGIS Pro platform. And once you become more accustomed to that, we'll use it to do more complicated analysis that'll be related to the things that I've been alluding to in the supplemental chapters from the Green Esri book by Andy Mitchell, the Volume 2, that I've been adding in and sprinkling in with the lectures the last couple of weeks. Alright, well, that's all I got for you. Try to stay out of the cold, try to stay warm, try to get your lab work done, and remember, the more time you spend working in Pro, the easier it will be to do the more complicated things that we're going to do later in the semester. Alright, have a good weekend. I'll see you all next week.